Welcome back to another Explainer. We've got a truly epic journey ahead of us today, and I mean epic in the most grand, cinematic sense of the word. We are going to bridge the gap between the roaring, electric crowds of a massive 1980 stadium concert and the pitch-black, fiery depths of Earth's geology. We're talking about the literal foundations of our planet.
Okay, let's just dive right into this mystery, because it's wonderfully bizarre. What could the legendary 1985 Live Aid concert possibly have in common with a massive 66-million-year-old pool of magma cooling beneath an ancient sea? It sounds like the setup to a crazy joke, right? How do you connect stadium-shaking pop culture with the ancient, rumbling forces of deep geology?
Well, the punchline is the calendar, July 13th. Globally, we know this day as a celebration of rock and roll, specifically that legendary 85 Live Aid mega concert for African famine relief featuring icons like Queen and Black Sabbath. But here's the twist. July 13th is also International Rock Day of the literal kind. It was chosen to honor the birthday of the legendary planetary geologist Eugene Schumacher. So on one hand, we've got the rock music that moves us, and on the other, the actual billion-year-old rocks beneath our feet. Today, we're focusing entirely on the majesty of the latter.
Let's kick things off with Section 1, Earth's epic building blocks. Before we get to the towering mountains, we have to start small, like microscopic. What exactly is a mineral? It's a distinction that actually trips a lot of people up. A mineral is a naturally occurring, inorganic element or compound with a highly orderly internal structure. Think of the flawless, pure geometry of a quartz crystal, or the carbon lattice of a diamond forged under crushing underground pressure. These pure, geometric structures, they're basically the atomic alphabet of geology.
And if minerals are the alphabet, well, rocks are the chaotic, sprawling novels. A rock is simply a solid aggregate of one or more of those minerals. They aren't orderly or perfect. They are compressed, messy, and forged in the literal crucible of the earth. Take a piece of common granite, for example. It's a rough, mottled mashup of quartz, feldspar, and biotite. And it's these chaotic mixtures that actually make up the Earth's rigid outer layer. We're talking the ground we walk on, the towering cliff faces, and the deepest ocean floors.
Which brings us to Section 2, the fiery rock cycle.
You see, rocks aren't just dead, static objects. They are constantly being destroyed and reborn in this incredible, dramatic engine we call the rock cycle. It plays out in three main acts. First, you have igneous rocks, born straight from cooling, molten rock. Next up, sedimentary rocks. Imagine weather and water relentlessly grinding down older rocks into microscopic fragments, which then pile up and compress over millions of years into these sweeping, beautiful layers. And finally, metamorphic rocks. This is where existing rocks get dragged deep, deep underground. The immense heat and crushing tectonic pressure literally bake and transform them into something entirely new without ever actually melting them. It's an endless loop of fiery rebirth.
Now, speaking of that fiery rebirth, here's a quick but absolutely crucial distinction. That molten material we just talked about, it goes by two different names depending on where it's hanging out. When it's churning and boiling deep below the Earth's surface, intruding into other rocks under unimaginable pressure, we call it magma. But the second it breaches the surface, say, violently erupting from a volcano and pouring down the slopes and glowing destructive rivers, that's when it officially becomes lava. Exact same epic substance, just a different location.
All right, let's look at what this all creates in Section 3, Myths and Majestic Formations.
First stop, picture the American Southwest, Bryce Canyon, Utah. Here you'll find these razor-sharp, towering stone pillars known as hoodoos. Geologically, they exist because a hard cap of rock protected the much softer rock underneath it from relentless rain and wind. Over millennia, the storms carved out a labyrinth, leaving only these thin, crimson spires. But if you ask the native tribes who lived among them, local legend says these haunting shapes are actually the petrified remains of evil people, frozen in stone forever by a powerful spirit. Next, imagine flying halfway across the world into the heart of the Australian outback to see Uluru. This massive rock formation almost feels alive. It literally changes color throughout the year, glowing an awe-inspiring rust red at sunrise and sunset. It rises out of the bush, surrounded by life-giving springs, and its surface is covered in ancient cave paintings. It is a place of profound, undeniable spiritual significance to Aboriginal culture.
From the sweltering outback, we jump to the misty, rugged coasts of Scotland. On the Isle of Skye, there's this striking 160-foot stone pillar called the Old Man of Storr.
Picture a post-dinosaur volcanic wasteland. Massive eruptions laid down heavy sheets of lava, and the sheer weight of it crushed the older, softer rock below, triggering catastrophic landslides. When the dust settled, this lonely, lumpy silhouette was left standing all alone against the wild Scottish weather.
Now, contrast that gritty volcanic coast with the serene, crystal-clear waters off New Zealand's South Island. Here sits Split Apple Rock, a giant boulder cleaved perfectly in half. Science tells us that relentless wave erosion patiently wedged apart a natural joint in the stone. But the Maori myth, it's absolutely incredible. It tells of two powerful gods fiercely fighting over possession of the rock. To resolve the dispute fairly, they simply split the massive boulder down the middle with their bare hands.
And geology merging with human faith doesn't stop there. High up in the mountains of Myanmar, there's the Kyaiktiyo Pagoda. Picture a massive golden rock seemingly defying gravity, balancing precariously on the very edge of a sheer cliff. Devoted pilgrims have trekked up there for centuries to cover it in thousands of layers of dazzling gold leaf. And the legend says the only reason this massive boulder doesn't plummet into the gorge below is because it is resting perfectly balanced upon a single strand of the Buddha's hair.
To wrap up our earthly tour, we head back to the USA, to Wyoming, for the ominous Devil's Tower. It shoots up 120 meters straight out of the sprawling wilderness. Remember our magma from earlier? Around 66 million years ago, a massive underground pool of it pushed up beneath an ancient seafloor. As it cooled in the pitch black, it contracted and fractured into these sweeping, perfect vertical pillars. Today, it stands as a sheer geological monolith that inspires incredible legends and challenges the most daring rock climbers on the planet.
Let's zoom out for our final chapter, Section 4, the Cosmic Rock Cycle.
Our connection to stone is quite literally baked into human evolution. Think about it. Around 30,000 BCE, early humans were grinding up minerals to paint stunning, lifelike art in Francis Chauvet Cave. In the Stone Age, rocks were our very first tech, sharpened tools for pure survival. Fast forward to the 1960s, and we're using our knowledge of rocks to navigate the stars. Eugene Shoemaker, the geologist we mentioned earlier, literally took Apollo astronauts into volcanic craters right here on Earth to train them. He needed them to know exactly which ancient rocks to collect once they were walking on the surface of the moon.
The mind-blowing takeaway here is that the rock cycle isn't just a terrestrial thing. It is totally cosmic. You've got meteorites, blazing chunks of rock and metal, slamming into Earth and carving out massive, violent craters. You have giant asteroids drifting in the freezing, dark orbits between Mars and Jupiter. We're even seeing rogue interstellar objects transferring geological material across vast stellar distances. The entire universe is essentially one massive, chaotic, interacting rock cycle.
And that brings our story full circle. Making Eugene Shoemaker's birthday, July 13th, the official International Rock Day? It is just perfectly fitting. Shoemaker was a pioneer who always looked past the horizon. By celebrating his birthday, we aren't just staring at the dirt under our boots. We're looking up at the impact craters on the moon. We're looking at the asteroid belts. We are honoring the majestic science of studying rocks across the entire solar system.
So, I want to leave you with this thought to ponder. We've seen rocks forged in fiery magma carve out the foundations of civilizations and drift across the freezing void of space. The next time you're walking outside and you casually pick up a simple, unassuming pebble, what are you going to see? Just a stone or a billion-year-old piece of an epic, ongoing cosmic puzzle? Thanks for hanging out with me for this explainer, and remember to always look closely at the amazing world around you.